Hello guys, welcome to Study B, and today we are going to discuss adsorption isotherms. So adsorption isotherms, what do we mean by adsorption, adsorbent and adsorbate should be first clear. Now what do we mean by adsorption? Adsorption means when the molecular species accumulate over the surface. It's a surface phenomena. The molecular species does not get into the bulk of the surface. It just surrounds the surface with some forces of attraction like van der Waals, then that is physiosorption, and if chemical bonding, then that is chemisorption. Now, this is the surface on which the adsorption takes place and is adsorbent, whereas the gas is adsorbate. Now, so I've written it over here because I'll be speaking in terms of this. Now, what do we mean by adsorption isotherm? Adsorption isotherm means anything that is happening at a constant temperature. We have studied about isothermal processes also. So the main condition here is constant temperature. Now, what is an adsorption isotherm? The amount of gas that is adsorbed by the adsorbent. Now this is the adsorbent, and the amount of gas it is absorbing at with pressure, with some amount of pressure at a constant temperature gives us the adsorption isotherm. Now what is Freundlich adsorption isotherm? So Freundlich was a scientist, and he gave a relationship that is given here: x upon m is equal to k p 1 upon n. What is this relation? So here x, first of all, what is x? X is the mass of adsorbate, of the gas that is absorbed. So mass of adsorbate, of the gas absorbed, mass of gas adsorbed, and m is mass of adsorbent, right? So mass of gas upon the mass of surface, just to remember, mass of gas upon mass of surface, right? This is equivalent to k p 1 upon n, p raised to the power 1 upon n. Now p is the pressure and n and k are constants. Now the value of these constants depend on the nature of adsorbent and adsorbate that are used. We are not concerned with that. The value of k and n varies for different adsorbent and different adsorbate. Now the relationship is generally represented in the form of a graph, right? So we'll be discussing graph. We'll be discussing various types of graph in this video. Now before coming to the graph, we should understand what is happening over here. Here x upon m is giving us the extent of adsorption. It is telling us how much adsorption is taking place. That is given upon, it is giving us the extent of adsorption, right? So we saw that one graph is given in your book, and this graph is this. Here x upon m, that is the extent of adsorption, where x is the mass of gas absorbed and m is the mass of what? Surface, mass of the solid, mass of adsorbent. And we saw that this graph is experimentally found out that this graph between x upon m versus p is given. Now what this graph is telling us, first we'll talk about high pressure. At high pressure, now this is pressure. At high pressure we see that at any temperature all of them are approaching saturation, right? They all are getting constant at high pressure, right? That means adsorption at high pressure becomes constant, the extent of adsorption. Now when we talk about a fixed pressure, say let this be a fixed pressure. So if we see at this fixed pressure, what do we see? We have taken it at different temperature. Now if you observe it carefully, then you will see that as there is an increase in temperature, the adsorption decreases. So its highest temperature in this graph is 273, but the extent of absorption is minimum out of these three, right? So these three conclusions can be taken out from the graph. Now in the next video we'll take the graph when we'll take log of this equation. So go and check that video also. It will be helpful to you. Thank you.